This is 6.4. We're going to talk about dot product of two vectors. Boys, this is not hard, I promise you. What have I told you about vectors when you're combining them? First goes with first. Second goes with second. Okay, if we can remember that, we're going to be okay. When we're talking about a dot product, all right, look how this is written. What does this look, what does this look like? That this is saying, U what? Looks like U times V. All right, it's not. This is called dot product. The reason that this is different, it's a raised dot in the middle that is bold. All right, it's a raised dot in the middle that is bold. But what you're doing, you're going to have two vectors. You know that you're given two vectors because they have the little arrow things on either end. You multiply the first with the first and the second with the second, and you do what to those two numbers? You add them together. Are we okay? All right, we're going to do a bunch of examples here. When they say let U, V, W be vectors in a plane or in a space, and let C be scalar. If you guys notice, all you're doing, these are just the properties. This is like multiplication properties that you guys are aware of. If you do U dot product V, it's the same as if you did the V dot product U. You guys see that? Number two, it says 0 dot product of V. If you multiply anything by 0, what do you get? Zero. Do you notice how you have a number 4? V dot product V is just magnitude V squared. Okay, this is nothing new. Nothing new at all. It's just because you're talking about vectors instead of points and stuff like that. So let's do some problems here. Okay. On your test, it'll tell you like find the dot product or something like that, so you guys aren't guessing, are we supposed to multiply? All right. So I told you guys, first goes with first. Second goes with second. Okay, so let's do letter A right now. If we're going to do the dot product, first multiplies with first. This is very easy to make silly mistakes, right? But if you're not paying attention. If you need to use different colors or something like that, fine. But first multiplies with first. So I have 4 times 2. And then I add plus what? 5 times 3. 4 times 2 is what? 8. And 8 plus 15 is? So the dot product of vector 4, 5 and 2, 3 is the value 23. Questions? Did I lose anybody? People at home, we okay? Yep, okay, great. Good talking to you. All right, let's find the dot product. So first with first, so I have 2 times 1, right? Plus what? Negative 1 times 2. So I have 2 minus 2, which is what? 0. We're going to put a star by that one. It means something. I'll show you in 1 second. Okay, let's do C. 0 times 4 plus what? 3 times negative 2. 0 minus 6 equals negative 6. How do we feel about dot products? Not bad. Not bad. All right. I told you that our example B was a little different. All right. It means something, right? If we were going to graph B. Okay, let's pretend, please, that this is the most perfect coordinate plane you guys have ever seen. All right, if I'm going to graph B, my first vector is 2, negative 1. So I go over 2 and down 1. I get this directed line segment like that. Now I'm going to graph the second one, and it's 1, 2. So I get a directed line segment like that. What do you guys notice forms in the corner at the origin on my most perfect coordinate plane ever? It is an intersection. It's an intersection at a 90-degree angle. What do we call it when two lines meet at a 90-degree angle? We call them perpendicular, right? In vectors, when vectors are perpendicular, it's said to be orthogonal. I think I spelled that right. All that means in vector language is perpendicular. Perpendicular. So if you are graphing vectors, if you have a picture and they meet at a 90-degree angle, you can say, oh, those are orthogonal, right? Now you're just so smart. How do you figure out if something algebraically is orthogonal? When you do the dot product, what is their value? 0. So if you're asked to prove if something is parallel or orthogonal or neither, if you do the dot product and the product is 0, the dot product is 0, then it's said to be orthogonal. Questions? Oh my gosh, this problem's so hard. It's really not, guys. The biggest thing is you have to pay attention. If I were you, I would write out U is -1, 3. Then I would say V is 2, -4. And I would say W is 1, -2. Write it right at the top so you're not looking all over the place for different things, because this is really easy to make silly mistakes when you're not paying attention. Right? Letter A says U dot product of V, and then what do I do? What does it mean that the W is outside of the parentheses? It means to do what? It means to multiply. It just means to multiply. So we're going to do the dot product first of U and V. What goes with what? Right? First with first, second with second. So dot product of U and V would be -1 times what? 2 plus what? 3 times -4. You guys agree with me? I'm just going to put this in a bracket, and then I'm going to put W down here. So figure this out. This is -2, correct? Minus 12. What does that give me? So I have -14 W. Now what do I do? Yep, I'm going to say -14, and I'm going to multiply it, or I'm going to distribute. I'm going to do scalar multiplication right here. So -14 times 1 is -14. -14 times -2 is 28. That is it. Questions at home? Anybody? We're okay? Thank you. All right, let's look at B. I'm going to write down the question for B. It says U dot product 2V. Okay, so let's just think for a second. What am I going to do first? I'm going to distribute the 2 into V, and then I'm going to find the dot product. You guys with me? Okay, so I have my U dot product. Let's do 2, and then I have V is 2, -4. Agreed? Yeah. Okay, so I'm still going to keep the U in the dot product there. 2 times 2 is 4, and 2 times -4 is? Now I'm going to replace U with what? With -1, 3, 4, -8. Now I'm going to do the dot product. All right, we're not multiplying them together. If they were being multiplied together, they would just be stuck together. I have that bold raised dot. That means dot product. So first stays with -1 times 4 plus second stays with, so then 3 times -8. What's -1 times 4? -4 plus, what's 3 times -8? -24. When I add -4 and -24, what do I get? That is it. Questions? We okay, people at home?
So B was using the same number?
Yep.
Okay.
That's how you'll be given on the test. So you'll probably have like maybe 6 questions that use, the same set of vectors. Just give some people some time to catch up. Sure. All right, let's look at the last one. What does the last one say? Yes, you do.
Is it absolute value of U?
It's not absolute value. Magnitude. Good. When we have the magnitude, guys. So everybody remember what magnitude is? How we find it? You don't even need the distance formula, remember, because you already have the vector. So you just take each piece of the vector and square it, and then add it together, take the square root. So what is vector u?
-1, 3.
All right, so I have -1, 3. If I'm finding the magnitude, this is V1, this is V2. Does it matter if you do V2 first and V1 or second? No. So you're going to say -1 squared plus 3 squared. 1 plus 9 is? One plus 9 is 10. So the magnitude of u is the square root of 10. Always, I'm going to write this in the video, and you guys are going to tell me, you never said that. We have to do that. Always, always, always simplify if you can. Can I simplify radical 10? No. I don't want the decimal equivalent. What I mean is if I get the square root of 45, if you leave that as the magnitude, I'm taking points off. Because what can you break 45 into? 9 and 5, right? So this would become 3 square root of 5. Why is it not plus or minus again? Because it's length. Again, this has nothing to do with the problem we just did. I'm just talking about simplifying. How do we feel? Oh my goodness, now we're talking about angles between two non-zero vectors. And guys, this is not a big deal, I promise. There's a formula. When there's a formula, it's easy. You just plug in all the stuff you have to find what you're missing, right? We're talking about an angle that's formed in between two vectors. You guys have seen this before. It's just now we're talking about vectors, not a big deal at all. Here is the formula. Okay, before you say, oh my God, what? Guys, break it down. Cosine. We all know where the cosine button is on our calculator. What does the numerator say? Thank you, Carlos. U dot product V. We just went over dot product. It's the easiest thing in the world. What does the denominator say? Magnitude of U times the magnitude of V. Easy, right? Very, very, very simple to make mistakes if you're not paying attention. But this process is not hard whatsoever. Let's do an example. Find the angle between these two vectors, okay? So let's write down the formula. It's cosine of theta. If they gave you theta, then you would just plug in theta and find whatever they're looking for. But it's cosine theta equals u dot product V over the magnitude of U times the magnitude of V. Now, you guys can do this however you want. I like to write everything out and then just simplify step by step. But if we do the dot product on the top, how do we find the dot product again? First times first plus second times second. So literally, guys, you're saying 4 times 3 plus what? 3 times 5. Does anybody have any questions? All right, now let's fill in the bottom. It's the magnitude of U times the magnitude of V. So the magnitude of U, how do we find that? Well, we're going to say 4 squared plus 3 squared, right? Under the square root. And then the magnitude of V. I'm going to multiply this by 3 squared plus 5 squared. Take the square root. Questions?
Will we multiply the denominator? Yeah, right?
Say it again.
Will we have to multiply the denominator?
Yeah, you'll be fine. Just watch though. Okay, so let's simplify as we can here. 4 times 3 is 12, right? Okay, plus 3 times 5 is 15. So what's 12 plus 15? 27. Now I'm going to simplify a little bit here. What's 4 squared? 16. And what's 3 squared? 9. What's 16 plus 9? What is it? Okay, so it's square root 25. I know you guys know what that is. I'm just going step by step. 3 squared is 9 plus 5 squared is 25. What's 9 and 25? I'm going to put this in parentheses. I'm not going to put a dot just so I don't confuse you. So I have square root 34. I'm leaving it just like that. If you want to make this a 5, that's perfectly fine. Square root of 25 is 5. So 5 times root. But you guys don't have to simplify anymore because what you're left with here is cosine of theta equals 27 over 5 times the square root of 34.
Now we have to find the cosine.
Uh-huh. Now think about this for a second. All right? Just think for a second. This is the cosine of theta. I want to find out what actual theta is. What's the opposite, guys, of cosine? Right? If we take the inverse, if what I do to one side, I have to do where? So in your calculators, you hit second cosine. Everybody do this with me. I'm going to hit second cosine. And then I'm going to put 27 divided by 5 times the square root of 34. I'm going to put the denominator in its own parenthesis. I'll see if it makes a difference. Hang on. 5 times. What'd y'all get? If you guys are getting error, that means your calculator needs a double parenthesis. So put in like cosine -1, then put parenthesis 27 divided by, then put another parenthesis. So 5 times the square root of 34, then you'll need 2 parentheses.
I have 22.17.
That is correct. 22.17 what?
Oh, no, wait, 6.
No. What's the notation that goes at the end if we're talking about theta? What did you just find? Yep, degrees. That's important, guys, because you're finding an angle measurement. But probably in your calculator, most of you will need this parenthesis here and here around the denominator itself. And then you have to have this one at the end to close off this one from the beginning. But you found the angle measure.
So how much is 22.17?
22.17 degrees.
I did something wrong.
Okay. Oh my gosh, we're talking about orthogonal. Guys, what did I tell you orthogonal? I told you like 3 minutes ago what orthogonal meant. What does it mean? What does it mean though? That the vectors meet at a perpendicular angle, okay? How do you know that they're orthogonal? How do you prove to me that they are? When their dot product is 0, all right? Everybody okay? Oh gosh, are these vectors orthogonal? On your test, if I give you a problem like this and you just write yes or no, I'm going to put a big fat X on it. You guys have to show me. How do you show me that they're orthogonal? We do the dot product. So it's 2 times 6 plus -3 times 4. What is 2 times 6? 12. Plus, what's -3 times 4? -12. What's positive 12 and negative 12? 0. Now you can say yes. We want lots of problems like that on our tests, right? You'd be so surprised at how many people get this wrong because they're just not paying attention. How do you prove that vectors are orthogonal? Using algebra. You do the dot products. If the dot product, you math. You do the math and then you show me the answer, right? If they are 0, then you're good to go. Okay, scooting along. Two vectors that are perpendicular, two vectors that are perpendicular are vectors that meet at right angles. We've talked about that already. Two vectors are orthogonal if and only if the result of their dot product is 0. Okay, we know that. Two vectors are parallel. Whoa. If and only if. What does it say? Look at it.
U equals A.
You take U and you put it over what? The V's.
Like U1 over U1.
We talked about what at the very beginning, we talked about parallel. The direction, it's slope, all right? So this is just a watered down slope version. So let's look at this. It says determine if U, V are parallel, orthogonal, or neither. Okay, let's write the vectors because it's written in that funny linear combination form. Let's write it in our component form. U would be what?
2 minus, or 2 negative 2.
Would be 2, negative 2. And V would be what?
Negative 1,
Negative 1, negative 1. How did Bella know that?
because of the,
She is smart, I agree.
well, no, because of
The coefficients, guys, are your vectors. Remember, the horizontal component, when you move left and right, is the coefficient of I. The vertical component is the coefficient of J, where you move up or down. That's it. So if they were parallel,
We'll never have J before I, right?
We'll
never have like.
No. If they were parallel, what did that last slide just say to do?
U1 over V1.
U1 over V1. So 2 over negative 1. Agreed? You guys okay with that?
Negative 2.
And then I take, this is U1, this is U2, this is V1, this is V2. So you take U1 over V1, did that. Then you take U2 over V2. Agreed? Okay. Is that a true statement?
Nope.
Is this a true statement, guys?
No.
Because they're not what?
The same.
The same. So they're not parallel. All right, well, let's see then if they're orthogonal. How do I find out if they're orthogonal?
If they equal 0, divide.
If the what equals 0? The dot product. So I'm going to say 2 times, I like green on the black, 2 times what?
Negative 1.
2 times negative 1 plus what?
Negative 2 times negative 1.
Negative 2 times negative 1. So 2 times negative 1 is negative 2 plus negative 2 times negative 1 is what? 2. Negative 2 and positive 2 are what?
0.
So what did you guys just prove?
It's orthogonal.
It's orthogonal. Okay. How do you know if it's not parallel if you didn't really do anything? I totally get what you're saying here. Is this a true statement? Is 2 over negative 1, which is what? What's the value of 2 over negative 1?
Negative 2.
Okay, so the value of 2 over negative 1 is negative 2. Wow, I don't want to write that. Is negative 2. Does that equal, what's the value of negative 2 over 1?
2.
Positive 2. Does negative 2 equal positive 2? No.
So can you tell already from there that it's orthogonal because it's...
Yes. Okay, Madison, wait, can't you just tell already that they're orthogonal? Yes, you can. But you have to prove it to me. I'm not asking you to prove that one identity is the same as another identity. I'm literally asking you to multiply some numbers and add them together and show me it's 0. So that's the proof. And that, ladies and gentlemen, is it for vectors and dot products. Okay, one extra example I want to do. If you're given the magnitudes and the angle, and then you are supposed to find the product of u dot v, okay? Our original equation is the cosine of theta equals the dot product of u and v divided by the magnitude of u and v, okay? So if they've given us theta and they've given us the magnitudes, we need to find the dot product. So if I was going to get this, if I wanted to isolate the dot product, because that is one number, it's one value, I would multiply both sides by the magnitude of u times the magnitude of v. That's a v. right? So what I do to one side, I'm going to multiply to the other, magnitude of u times the magnitude of v, and that'll give me my dot product. So these two cancel out, so I'm left with the dot product, u times v, that's one value, is going to be the magnitude of u times the magnitude of v times the cosine of theta. So in this case, guys, they gave us that the magnitude of u was 4. They told me that the magnitude of v is 18, so 4 times 18, and then cosine theta. You guys could do cosine theta in your calculators, and you'd get cosine of pi over 3, which is 60 degrees, is 0.5 or 1/2. Or you could look at a unit circle and say cosine is the y value, right? But if they don't give you something, it's best to use, I'm sorry, cosine's x value. It's best to use the values, if you can, off of the unit circle. So I can give you a unit circle if you need one. But you would simply multiply 4 times 18, which is 72, and then multiply that by 1/2, or same as 72 divided by 2. So you get that the dot product of u times v equals 36. So you'll have some web assigned questions like that. So just make sure that you guys understand. If you're looking for the angle, then you use the original formula of cosine theta equals the dot product, u times v over magnitude u times the magnitude of v. If you use this when you're given the two vectors, all right? You use this one over here when you are given magnitudes, I should say, and theta. So just depending on what they give you, it depends on which way that you would manipulate the formula.